Welcome to another episode of Crimes Notes. Today we're going to be talking about function notation. Now, I know it's going to look very complicated, but what I want you to know is that you already know how to do this. In our warm-up problems, or even previously, you guys have learned that if you were given a function, let's say y equals, well, let's not even do y equals. If I said 2x plus 3, and I said evaluate for x equals 2, then all of you know that you would take 2 and you would substitute it in for x. So the equation would be 2 times 2 plus 3. And then we could type this in our calculator and it would spit out and tell you that the answer was 7. What we are doing today is function notation is the exact same thing. So we are still going to just be evaluating equations for certain values of x, except for they're not going to write it in that many words. So instead of saying evaluate this equation for x equals 2, they would say that the equation is f of x equals 2x plus 3, and they would say find f at 3. Well, notice I replaced the 3, or the x, with a 3, which means we would do the same thing in the equation. And so it's still saying the same thing, 2 times 3, and then plus 3. So now we could put this in the calculator, and it would spit out an answer of 9. So function notation is not going to be anything different from what we've been doing. It's just going to be written in a different fashion. So it can be written in two formats, y equals or what we call function notation. So the original y equals 3x plus 5, if we were told to write that in function notation, we could change it to f of x equals 3x plus 5. If they gave me y equals 2x squared plus 1, and they wanted me to write it in function notation, I could write f of x equals 2x squared plus 1. Now, please remember, these can be any letter. This one could actually be changed, and we could say this is t of x, okay? Or the same thing here. The original format was y equals x over 3 for this function. We could actually say that this was g of x equals x over 3. It doesn't matter what this letter is, okay? It's still going to be function notation. So now I want you to write your own equation in y equals, and then you change it into function notation. So the f of x format is called function notation. It gives functions a way to be recognized. So that's one of the benefits. It gives different functions a specific maybe / unique name. In other words, I can call f of x different from g of x. So if I was talking up here and I said, look at the function g of x, well, now you know I'm talking about this function right here. But if I said, look at the equation y equals, well, there's a whole bunch of those, and so we wouldn't really know the difference, okay? And then it can be used to designate a specific value. So again, if it's written as f at 2, it means find the function f, so the rule, or you can put the function, or another word for that would be the equation, named f, and substitute in a 2 for the variable, which is what we were just talking about. This is another way of saying this right here would be the same thing as saying x equals 2, and they want you to substitute it into an equation. So we're going to look at some examples down here at the bottom. Let me, as usual, fold the paper so that you guys can see it. So our first example says that our function is f of x equals 3x plus 5. Now notice, if we were looking at the example 1, 2, 3, and 4, and I said find the function f of x, you could immediately know that it was this one. If I said find j of x, you would be able to find it quickly as well because it's right down here. But it's harder if I just say find the function and I don't give it a name. So if this was our equation, it's now basically telling you to evaluate f at -2. So basically, remember, this is telling you that x equals -2. So that means basically I want to replace x in this equation with -2. I'm not going to do anything with the f of x. So I'm only looking at the equation part. So I'd go ahead and write down the 3. But now x is -2. So I'd put that in parentheses. And then the last part says plus 5. And I should have written that below the line. Sorry, but I didn't. So now that would be calculator ready. And so we could go ahead and plug it in. 3 parentheses -2 close and then plus 5. And it says -1. So really this should be down here and the -1 should be up there, but since I wrote in pen, I can't really make that happen. So now what if they give me a fraction? Well, remember, they're still telling you that x equals 1/3. That's what this means. So I'm going to go back to my original equation and I'm going to replace x with 1/3. So now I'm going to do it the right way. So 3 parentheses 1/3 and then plus 5. And now it would be calculator ready and I could go ahead and put that in. 3 parentheses control divide will bring up that fraction bar 1/3. And then come outside and put plus 5, enter. And it is 6. Good. So now let's try 0. Again, I'm just replacing x, or the variable that's in the equation, with 0. So this would be 3 times 0 plus 5. And I'm going to kind of stop showing you how to put it in the calculator just to save us a little time. So this would end up being 5 if you put it in the calculator. All right, so what happens when we have this funky little negative sign that's in front? This is super important. So if there's a negative in the front, and what I want you to do now is if you have a highlighter, highlight it, and then I want you to come down to the bottom over here in the corner, and I want you to go ahead and highlight that one so that you don't forget. Okay? But when there's a negative in the front, what we're going to do is put a negative, and then we're going to do exactly what we would have done before. X is 5, so now I'm going to replace. So 3 times 5, and then plus 5, and then close. So I can either type this all in at once, negative, parentheses, 3, parentheses, 5, close, plus 5, close, and press enter, and it tells me that this solution is -20. The other option would be that I could put this in, and if I just typed this in, it would tell me that inside my parentheses I have 20, and then I would have this negative out here that would make it -20. But as long as you have a calculator, you might as well use it. And so you might as well just put it in there all at once. All right, so let's look at these next two. These are a little different, okay? It's kind of strange, but it says find f at j. Well, that means they're telling us that now x is equal to j, which kind of seems odd. But we're still doing the same thing. We're just going to replace the x in the equation with whatever they gave me, so with a j. So if I take our normal 3 and I would leave a parentheses for whatever value of x and put plus 5, well, now I would just be putting a j in here. Well, 3 times j is just 3j plus 5. So if you notice, it's the exact same equation, except for I just changed the letter. I went from x to j. So if we use that same idea, we've got f at g. I'm really just replacing the x with a different letter. So I would just put 3g plus 5. Now, the funny thing is you can do this with anything. It doesn't even really have to make sense. So let's say I said, let's do, for this one, let's do f at heart. Well, if I wanted to do f at heart, that means I'm going back to the original equation and I'm replacing the x with a heart. So now it would read 3 heart plus 5. Now, it doesn't really make any sense, and I can't really replace it mathematically, but the idea of function notation is the same. So I could replace it with anything that I wanted to. Okay, so if you notice, I've given you a couple of examples with a smiley face and with a star. So just remember, it doesn't have to make sense, you can still replace it. All right, so let's look at some of these other ones. I'll do a couple of random ones for you. So let's do g at 2. Again, this capitalization shouldn't be there. It should be lowercase. But remember, this just means that we want to replace x in this equation with -2. So down here below, this would be 2, and then I would leave parentheses for my x. Then notice the exponent, so this would be squared, and then plus 1. Well, if I replace x with -2, this is what it would look like, and then it would be calculator ready. So if I go ahead and put this in, 2 parentheses, -2, close. Our squared button is right here. I don't know, right next to the 4, squared. Then make sure you come back down and then put plus 1. Again, if that plus 1 is still up high, then you messed up. And then press enter, and we get 9. Good. All right, so then let me give you an example for number 2. On number 2, let's go down here and do the fraction. Again, remember, we're just replacing x with 1/3. So remember, my equation is x, whatever x is, over 3, right? Well, in this case, x is 1/3. So that means I'm putting 1/3 on the top of the fraction and 3 on the bottom. So if we go to put this in our calculator, let me get that glare off of it. There we go. We would do control divide so that we already have this. On the top, we have 1 divided by 3. And you can either do it that way, or you can put, we could do control divide again and put 1/3 in the top. And then on the bottom, put 3. And it says 1/9. So this answer would be 1/9. Good. All right, so I'll leave the rest of those for you. I think these other equations are pretty self-explanatory, so I don't really think that you need any help on those. But please, please, please don't forget this part right here where you have to do the -m. Okay? Now, I want you to go ahead and finish the front before you even go to the back. So finish the front first, and then you can come back and watch the second video.